All right, hello everybody. This is the review for our Unit 11 parametric test. There's only 10 questions on this test, and with those 10 questions, the first 4 questions all have to do with this same problem situation like this one. And in this, you have a particle that moves so that its position at t seconds such that your t value is between 0 or 7 seconds is given by the following formula. Okay, in this is our x equation, this is our y equation, and these just tell us our horizontal and vertical movement over a given period of time. And the first thing that you will need to do with these two equations is find the rectangular form of the equation. Now the question doesn't say find the rectangular equation, it just says create an equation that shows y in terms of x. Okay, in this case we are looking for, remember with the rectangular equation you have one of your variables on one side of the equal sign and everything else with the other variables on the other side. And this time we want y in terms of x, so y is going to be on the left side and x and all our other numbers are on the right. So to do that, we're going to first take our x formula and we need to solve for t. Okay, so to do that we need to add 1 to both sides of the equation. And that leaves us with x plus 1 equals 2/3 times t. We're going to have to divide by 3 and we're going to have to multiply by 3 and divide by 2. And you guys should know by now that I want you to keep, instead of having just one massive fraction, go ahead and separate your two terms. So you'd have 3/2 times x plus 3/2. And then this formula here for the t value is going to get put into your y equation. So here's the y equation, and all we're doing is replacing t with the 3/2 times x plus 3/2. Okay. Now in this equation we're squaring the term, so we can either FOIL or we can use the box method. In class this past week I've demonstrated the FOIL method a couple times. In this video I'll remind you guys how to use your box method. You just draw 4 squares, and on the top you are going to just put the two terms in your factor here. Your 3/2 times x goes above this box, and 3/2 goes over this box. Okay, we're going to do the same thing on the sides. Okay, and then what you do is for each of these boxes you're going to multiply whatever you have on the column by whatever you have on the row. So right here you would end up with 9/4 times x squared. Okay, here you would multiply the 3/2 times 3/2 times x. You would get 9/4 times x. And then same thing here, you get the 3/2 times 3/2 times x. And then here you get 3/2 times 3/2, and you get 9/4. Okay. Once you do that, you combine all like terms. This term is all by itself, so that's going to be out front. Then these two terms combine to give you 18/4 times x. And then your last term is just 9/4. And don't forget, at the end of this equation, we have a -7. And at the beginning of the equation, we have this 4 there. So when we are doing that, if we distribute the 4, that takes care of all of our denominators of 4. And so our final formula, well, not our final formula, the second to the final formula, we get all this. Then the last thing we have to do is combine these two last terms. And so our final rectangular equation is right here. Okay. So now the next thing we want to do with our parametric function is figure out the domain and the range. Now remember, we wanted to find, or the limit on your parametric function was that t had to be between 0 and 7. So you're going to take the x formula and plug in 0, find out what you get. Do the same thing, but this time plug in 7, find out what you get. And then do the same thing for your y formulas, plug in 0 and 7. When you do the math, you end up with -1 here 11 over 3 here, negative 7 here, and 189 here. Okay, now to figure out which controls the domain and which is the range. So this number is going to be the beginning of my domain. This is going to be the end of my domain. This number is going to be the beginning of my range. This is the end of my range. Okay, so your domain ends up being negative 1, comma 11 over 3. And then the range is negative 7, comma 189. All right, hopefully this wasn't too hard. It should be pretty easy. The last thing that you need to do is sketch a graph of the position of the particle. Okay, and honestly, you can either use your parametric function and graph it, and make sure you change your limit from 0 to 7, or you can go back and you can go back and graph the rectangular function and then just set the limit like I showed you in class earlier, a couple days ago. Okay, either way, just remember that this is going to be a multiple choice test, and I'm not going to tell you what window to use, but if you know how to graph it, then you should be able to look at the 4 pictures and say, hey, this is the picture that looks most like what it's supposed to be. If you end up with, let me do this. If you get a graph where, let's say your graph goes like this, way over here in the second quadrant, then you know that this picture is not the right thing. Okay, so you don't have to, you may have to change the window a little bit to get a good idea of which graph or which of the 4 options is the correct option. However, it's not super hard. As long as you know how to graph the equation and you know how to set the limits, you should be fine on this question. All right, here's another type of problem. You have a ball is thrown at an angle of theta degrees above the horizontal at a speed of 91 feet per second from a height of 65 feet above the ground. Express the position of the ball using a set of parametric equations. Okay, this one, just make sure you know how to set up your X and Y formula when you're throwing things through space. Okay, and notice you see the word feet several times, and so that helps you know what formula you're going to use for the gravity. Now the speed is your magnitude. That's the first thing that's going to go in your X equation. So the 91 feet per second is your speed, and then times cosine of the angle. And with this one, they don't even give us an angle, they just give us theta. So you just put theta there, and then don't forget to put the times t in the equation. And then for the Y formula, there's several different parts, and realize it's going to be multiple choice, so you just have to make sure that all the correct parts are in the equation. They may be in any order. I know in class this week you probably saw your what is normally your second term in a quadratic equation. You saw that at the beginning. In this example, I put it in the middle, but it really doesn't matter what order you have these terms in as long as you have all the terms you're supposed to have. Okay, so let me just go ahead and start uncovering it. We know that the Y formula is going to have the same basic thing here, except it's going to have sine instead of cosine, and I believe I put that in the middle on this one. Yep. And then we also need to have the effect of the gravity, and because we have our measurements in feet up here, we're going to use minus 16 t squared. And then the last thing that you need to have in here is your initial height, and our initial height here was 63 feet, so that's going to be here. Now notice I have this equation, and pretty much everything is word for word. All my numbers are the same, except for on this one I have meters, meters, meters everywhere. Okay, so my unit of measurement are all going to be in meters. Your X formula is going to be exactly the same. That's not going to change. Your initial height is going to be the same. Your middle term, the 91 times sine theta, is going to be the same. The only thing that would change would be you would subtract by 4.9 t squared instead of 16 t squared. I'm pretty sure most of you have already gotten this. It's not a hard thing to remember. If you think you're going to forget, go ahead and write it down on your paper, on your index card. All right, next question. An object is thrown off a cliff 100 meters high with an initial velocity of 18 meters per second and an angle of 67 degrees above the horizontal. How long is the ball in the air? Okay. Now for this one, first thing you need to do is find the y equation, and because we're in meters, remember you're going to use minus 4.9 t squared. Okay, and so initially we have our velocity of 18 meters per second, and then the sine of 67, since those are our angles, and that's times t, and then minus 4.9 times t squared, and then the height of the cliff is 110 meters high. Okay, so if, let's say we're throwing a water balloon, a frisbee, whatever, it doesn't matter what it is, we want to know how long is it going to take to land on the ground. And so our y value, we're going to set this whole equation up here equal to 0. Okay, so initially that's our first step, setting it equal to 0. Now we need to solve for t, and I know you guys don't like it, but use your quadratic equation. Just make sure you have the terms in the right order. This is, let me go ahead and label those. This is going to be your b value from here to here. That's your b value. This is going to be your a value, including the negative sign. Don't forget to include that negative sign. And then this 110 is your c value here. Okay? So setting that up, sorry about that, guys. Let me just uncover the whole thing, and then I'll tell you the precautions. Make sure you have the minus sign out here, or excuse me, negative sign out here. Make sure this is in parentheses and then double parentheses here before you square it. Minus sign, negative sign, multiply, make sure all of that's in there, and don't forget the negative sign down here. Okay? And you're going to plug this whole thing in your calculator, and you're going to push enter, and the calculator is going to give you an answer. And then this is our answer so far. And then remember, with the quadratic equation, first you do it with a plus sign, then you're going to do the exact same thing with a negative sign. Okay? Hopefully most of you realize that on your calculator you can just, instead of retyping everything in again, you can just scroll up, highlight the equation, push enter, and then move over to this and change this to a minus sign. Okay, the second time you do that, you get the 6.72 seconds. Okay, give me a second. Yeah, all right. And anytime you use your quadratic equation, you're always going to get two equations. In this case, we get one that's a positive value and one that's a negative value. We don't care about the negative amount. That doesn't apply to this problem situation. We want this positive answer. So don't be surprised if you don't even see this as one of the answer choices. We want this answer here. Okay, let's look at our next question. You have a set of parametric equations that describes the position of a football thrown by an NFL quarterback as a function of time is the following equation. So all we have is this huge equation, and then in this review you just have to fill in the blanks to make each statement true. I believe on the test you have to figure out which of these are false statements, and depending on the version of the test you have will determine which of these underlying things I've changed to make it false. Okay, so if you know how to fill in the blanks, you should be able to answer this question very easily. Okay, so a ball is released at blank above the ground. Okay, so we want to know how high is it above the ground. And notice there's no units of measurement. We don't have feet and we don't have meters. So how do we know if the measurement is in feet or meters? Well, remember that we use 4.9 when our units of measurement are in meters, and we use 16 when our measurement is in feet. Okay, so because we have a 4.9 here, all of our units of measurement are going to be in meters, and the initial height is the constant term in the y formula. So the ball is released from 17.3 meters above the ground. And then the next statement, a ball is thrown at blank above the horizontal. Okay, so anytime you see the word horizontal, that has to do with your direction. And notice that our degree is 12 degrees. So the answer will just be 12 degrees above the horizontal. The ball is thrown at a velocity of blank per second. Okay, and this number here and this number here is our speed, and it would be 59 meters per second. So if I wanted to make this the wrong answer, I might say 59 feet per second, and that would make the statement false. Okay, so both look at your numbers and look at the units of measurement. Okay, and then the last one, and the acceleration due to gravity is blank per second, because we have the acceleration due to gravity is the 4.9 meters per second, and that is the answer there. All right. Hopefully you would be able to answer this question super fast. This should be a super easy test. Okay, the last three questions all rely on the same problem situation here. Suppose that Arnold hit a golf ball with an initial velocity of 109 feet per second at an angle of 34 degrees above the horizontal. Okay, so you have three questions. You want to know what is the flight time of the golf ball, what is the maximum height of the golf ball, and then what is the horizontal distance that the golf ball travels. Okay, for all three of these, you first need to figure out what your parametric functions are going to be. And because our units are in feet, then our y value will have the minus 16 times t squared at the end. Sorry about that. And then, let's see, our speed is 109 feet and our angle is 34. So we have 109 times sine of 34 for our y formula, 109 times cosine of 34 times t for our x formula. Okay, so those are the parametric functions that we're going to use. Now let's figure out what to do to figure out what the flight time of the golf ball will be. So when we talk about flight times, we want to know when is, let me draw a little diagram. If I hit the golf ball, it's going to go up, it's going to go out, and eventually it'll fall back to the ground. Okay, I want to know how long does it take to get all the way back to the ground. And for that, my y value or my y equation is what I'm going to work with. And I'm going to set my y equation equal to 0. And I have to solve for my t values. Now, most of you are saying, oh man, I have to do the quadratic equation again. You actually don't have to do the quadratic equation again because the golf ball starts at the ground here, so I have no initial height. So this time, all I have to do is factor out my greatest common multiplier, and in this case, I have a t in both this term here and this term here. Both contain at least one t. So I'm just going to factor out a t, and I get t times 109 times sine of 34 minus 16 times t. Okay, notice that this t isn't here anymore, and this t that was squared up here is no longer squared. It's because we factored out a t. Now I'm going to set both factors equal to 0. So I get that your t value will equal 0, and then t can also equal all of this mess here. Okay, sorry, I skipped a step on you. So this factor is going to be set equal to 0. Then you need to solve for t. So you subtract it by 109 times sine of 34, and then you divide it by -16 there. Hopefully I didn't confuse too many of you. You're going to plug all of this in your calculator, and you push enter, and your calculator tells you that your answer is approximately 3.81 seconds. And so what is the flight time for the golf ball? Approximately 3.81 seconds. Okay, now we want to know what is the maximum height of the golf ball. Well, with parabolas, I did not do a very good job of making this look like an even parabola. Sorry, guys. Let me see if I can do a better idea. I'm going to do it this way. Just bear with me for half a second. Yes, I know that is not a parabola, but there we go. Now I have a parabola. I'm good, aren't I? It's a video. Nobody's paying attention to you, so just go ahead and say yes, Miss Pi, you're awesome. All right, so here's my parabola. I'm hitting the golf ball here. It's flying through the air. It's coming down here. Well, what is the maximum height of the golf ball? I'm going to hit the maximum height of the golf ball exactly halfway through the flight path, okay? If my time in seconds is 3.81 seconds, then half of that value is going to tell me when my height. So again, I'm working with my y equation, and I'm just going to plug in the 3.81 divided by 2, okay? And yes, in the calculator, because we're using the answer from here, I don't want you to actually type in 3.81. I want you to scroll up on your calculator and highlight the full number and then bring it into the equation to use, okay? So we're going to have 3.81 divided by 2 here, and we're going to have 3.81 divided by 2 here. This one, make sure you square it. Make sure the squared is on the outside of the parentheses. Don't just square the 3.81. That'll mess up your equation. All right, so you just set it up like that, plug everything into the calculator, you push enter, the calculator tells you that the golf ball is approximately 58.049 feet in the air, and so your maximum height of the golf ball is 58.049 feet, okay? The last question for this review. Okay, so we found the flight time of the golf ball, we found the maximum height. Now we need to know what is the horizontal distance the golf ball travels again. So far we found the time it takes to get this far. We found the maximum height. Now I want to know what is my distance from here to here. To do that, I'm going to take my x equation, and most of my students that get this question wrong, it's because they try to use half of the flight time, because that's what they did with the previous problem. You're not going to use half of the flight time, because I want to know the full time, how long it takes I want to know the distance the ball travels when it first gets hit to when it lands on the ground again. Okay, so I'm using the 3.81 into my x equation. I just plug it in, I push enter, the calculator gives me the answer, and I am done with the test. Okay, hopefully this was not too complicated for you guys. I will have tutoring on Monday. Come in for tutoring if you were really completely lost in this review. All right, bye guys.